Hi, my name's Kevin Farley. I'm a Senior Program Manager in the Microsoft SQL Server product group. And we're going to talk today about enabling backup on secondary replicas within AlwaysOn availability groups. The feature that we call Active Secondaries is all about being able to make use of what has previously been idle hardware in your DR configurations. So previously, when you had a database mirroring environment, you had typically a completely duplicate set of hardware sitting there, keeping up to the instant in sync with your primary, so it has a complete duplicate of all the data, and its purpose in life is to keep in sync with the primary data. In case anything happened to the primary, it could take right over without skipping a beat. And that failover time is important. It's really quick, but you can't make any other use of it. So all the other workloads that you would think you might be able to make use of on a secondary, you don't get any of that. With active secondaries, that's all about now being able to utilize that DR hardware, the secondary hardware that's been sitting out there where you've been paying for the hardware but not getting value out of it. Now it's about getting value out of that hardware. So you can offload your reporting workloads with read-only connection to the secondary, or multiple secondaries if you want, and you can also offload your backup. That has a lot of benefits. Not only are you just getting some value out of that hardware that would otherwise be sitting there, but it also does good things to the performance of both the read workloads on the secondaries as well as your production workload on the primary. For the reporting workload, you have the reports which have to pull data out of the database, and data gets staged in the buffer pool, which is a large area of memory that SQL Server uses to stage pages in memory as a hot cache. The pages that the reporting workloads need in the buffer cache are typically not going to be the same as the pages that your update application is going to need in the buffer pool. So they're fighting over that scarce resource of the buffer pool pages. The report takes pages away from your production update workload and vice versa. So neither one of them is running as fast as it can because you're flushing pages out of the buffer pool to make room for the other application's use. If you then separate them and run the reporting workload on a secondary, it can have all the pages at once in memory, hot, ready to access, and as well your update workload can have the pages it needs in buffer pool without any interference. So on both sides you get more predictable performance because you've got the pages you want and nothing else, and better performance because you're accessing pages out of hot memory rather than having to go out to disk to refresh them. So both sides benefit. Same with backup. SQL backups will monopolize the I/O system if at all possible. But essentially the only thing that slows down a SQL Server database backup is when we completely saturate the I/O subsystem. Other than that, we'll just keep pulling data. There's almost no CPU used. Even if you're compressing the backups, there's very little CPU that's used. So if you have a production workload that's trying to update data that has to be persisted on your disks, competing for that I/O bandwidth with backup, which is just sucking up everything it can get, they're both going to suffer. The backups are going to slow down because they're not getting all the I/O bandwidth that they want. As well, your update workload is going to suffer. Active secondaries resolves that as well by letting you offload your backups onto secondary replicas so they can have all the bandwidth that they want, and meanwhile your production workload goes on unhindered. So we're going to step back a little bit and talk about the current situation with backups within a database mirroring environment, which is what is the precursor to always-on availability groups. We're going to contrast that then with the situation now with backup on secondary within active secondaries. We'll talk a bit about what features this brings to the table and some of the limitations with this current release. We'll demonstrate what backups look like. We'll also demonstrate how you restore an environment where backups may have been taken on various different nodes, and you have to stitch those all together into a coherent restore plan. And then we'll have a discussion about automating backups in this environment. If you've got an array of nodes which any one of them can do the backups, how do you choose which one is going to do the backups? And having made that choice, how do you adjust when a new node gets added to the group, or node gets removed, or just there's a failover on which node is primary? That can be a tricky problem, and we think we've delivered a pretty slick solution for it. So we'll talk about what people do in database mirroring environments, which also is a smaller version of the same problem. What we're delivering with the backup on secondary solutions, how to do the configuration, what the options are there, some examples of how you might want to configure it for different situations, and then we'll show you what it looks like in practice. Live demos are always a good thing. So today in database mirroring and backups are only allowed on the primary replica. If you try and do a backup on the secondary, you're going to get an error message that says this node cannot be used for backups because it's in a mirror. The secondary replica therefore can't be used for backups, so you can't offload any of that workload onto your separate secondary. That means that your backup workload impacts production server. With active secondaries, offloading your backup onto secondary replicas, now backups are allowed on any replica, and that's an important point. It can be either sync or async. You can still do your backups on the primary if you choose, and there are some reasons why you might want to do that, which we'll get into. But also you can leverage your secondaries. That means if you choose to offload your backups onto secondaries, the backup workload is not going to impact your production server in any way. And it's a very highly requested feature. I first got into the SQL backup space about the time that SQL Server 2005 shipped, and that was the first iteration of database mirroring. And from the time that people saw database mirroring and started actually using it, I started getting requests, how come we can't do backups on the secondary? You got to let me do it. The database data is all there, it's sitting there, I know that it's up to date, how come I can't just get to it and back it up? That's what we're delivering. So we're solving that problem, giving you the feature that people have been asking for quite a while. Database mirroring backups, you have one primary, one secondary, primary mirror in that terminology. Your read-write workload, along with any read-only workloads, are attached to the primary, and backups also run on the primary. If you try and do backups on the secondary, it doesn't work. Secondary's job is just to keep up to date. It doesn't really get to do anything else. If there's a failure, or for any other reason there's a failover, and the nodes switch roles, now the read-write workload obviously has to connect to the primary because that's the only one that can be updated. And the secondary, if you had a backup job running there, it would start failing. If you had a backup job on the node which is now the primary, that would succeed. Active secondary, in contrast, you can have multiple secondaries, not just one, and backups would work on all of them. So you could potentially do backups on all nodes at almost the same time. You can't do it exactly the same time because there's locks involved, but in general, you can do backups on all the nodes. Probably you want a more coherent strategy for deciding which node at any point in time should be doing the backups, and we'll get into how we make that easy. The point here is you can do backups wherever you choose to do them. The capabilities this then brings to bear is that you can do backups on any replica of a database. The secondary replica that you're doing the backups on can be sync or async. So even if you have an async replica that is somewhat behind, you can still do reliable backups on it. Of course, if a replica were to be for some reason significantly behind, say 5 minutes, 10 minutes, an hour, then the secondary can't back up data that it hasn't gotten yet. That should be obvious. But typically a secondary replica is going to be within seconds at most of the primary, and most people can tolerate that amount of exposure for the gain of not having the production workload disrupted. And again, even though the backup won't have the very most up-to-date data, the next iteration of the backup will pick up the same data. There's no data ultimately exposed. You'll back up all the data. It just won't have the last up to the instant data. Backups on your primary replica still work. So we're not taking anything back. If you've got an environment where you do your backups on the primary and you're happy with that, that still works. We haven't taken anything back. And in fact, the automation solution will make it easier for your backups to run reliably on the primary in the face of failovers and which node is the primary moving around. It'll adjust itself. Log backups on all replicas form a single chain, and that's an important point. So regardless of which replica a log backup happens, the contents of the log backups do not overlap. So you need all of them, all the backups, regardless of where they were done, to form a complete restore. In order to do that restore, there's a new feature in SQL Server 2012 called the Recovery Advisor, which makes restores simple. This is a feature which bears some explanation on its own because it's a pretty cool feature. Previously, if you're doing a restore which involved a full backup and a series of log backups, maybe a differential thrown in there, you had to gather all your backup files together, figure out which order they were in. Hopefully you embedded the timestamp in the file name so you could easily sort through them and figure out which ones are in which order, and then do each of the restore operations separately in series in the right order. Otherwise we throw you errors. So it can be a picky and laborious task to do a roll forward in time. And it struck some of us as being rather unintuitive, since SQL obviously knows what backup has to be done next. It knows what backups it's done. It can look inside the backups and find out what range of data is in each one, and has all the information essentially that it needs to put together the proper restore strategy, order of operations, and what it has to do. But we made you type it in, and we complained at you if you got it wrong. The Recovery Advisor finally takes all that and makes it just really nice and simple. So what you do with the Recovery Advisor is an extension of the existing database restore wizard in Management Studio. So you pick a set of backup files. So all the backup files you think you might need to do this restore. You'll get a list of what databases are represented in those backup files. You pick the database you want to restore. Give us a destination for it. Where do you want it? Do you want it to override it? Do you want it to be a new name and new location? However you want that to be. And then tell us what point in time you want the restore to be as of. Is most up to date, which is the default setting, or some point in the past. And we even present a graphical view of what your options are, what range of time we can cover with the backup files you've given us. Once you set that time, you hit go, we do the rest. We'll apply all the restore operations in whatever sequence we need to do them in order to get your database to the point that you requested. One click, nice and simple. So that's what makes it rational to do a restore in an environment where you may have a lot of different backup files in a lot of different locations. Getting back to the non-overlapping log backups, if we have a simple two replica configuration, we have log backups that alternated between them. So the first backup was done on replica 1, the next in replica 2, the next replica 1 again, and the last one back in replica 2. You'll notice the designation LSN 1 to 10, 11 to 20, etc. Those represent log sequence numbers, and log sequence numbers are designations for what transactional data is in that backup file. So what transactions were included in that transaction log backup. And you'll notice that the log sequence numbers don't overlap. So in order to replay all those transactions, you would need all of those backup files. So you'd need to apply the log backup from replica 1, and then the next log backup that was done on replica 2, back to replica 1, etc. So that's just illustrating that you can't do duplicate log backups on both nodes because there's no duplication of the content within those log backups. How does all work behind the scenes, underneath the covers? there's a conversation that happens between a secondary that is doing a backup and the primary node at that point in time. When a secondary starts up a backup, the first thing it does is it contacts the primary and notifies the primary that it wants to start a backup. The primary at that point then will attempt to take out a bulk op lock for that database. This is the same lock that is taken out today anytime you do a backup, and it's what keeps you from doing two concurrent backups of the same database at the same time. Two concurrent log backups or two concurrent database backups of the same database. It's the same lock that we've always taken out. It's just now the primary will take it out on behalf of the secondary that's doing the backup. And what that does is if another secondary tries to do a backup at the same time, it will request the same lock from the primary, and the primary will reply, nope, that lock's already taken out, you can't have it, the backup fails. And that's how we keep from having log backups that overlap each other in content as well as time. Presuming that the primary is able to get the bulk op lock, that nobody else is already backing up that database, the primary will take out that lock on behalf of the secondary and reply to the secondary, you're good to go, start your backup. The secondary will then do the backup locally, so all the processing in this stage is done on the secondary. It's going to copy data out of the log, transaction log or the database, if that's what you're backing up, and output it to the backup media, which is local or wherever you happen to put your backup media. During this phase, for backup purposes, there's no interaction with the primary. When the secondary is done with their backup, it's going to send notification that it's done back to the primary, and it will send in that notification package the log sequence number that was active in the log at the point that it stopped copying data out of the transaction log, because even database backups copy data from the log. So this is the record of what the last backup LSN is, gets sent to the primary with that package. The primary will then update the last backup LSN in its copy of the database, which is the updatable copy, and that's the one that is used for the next backup. So that update of the last backup LSN now gets made on the primary and replicated out onto all the secondaries. So at the close of this operation, all of the secondaries have the same value for the last backup LSN. And the next time anyone does a log backup, it starts just past the last backup LSN, which everyone has the same view of. So in that way, before the bulk op lock, everyone gets the same value of the last backup LSN, or at least it is updated before the bulk op lock is released. And that's how we guarantee that there is never any overlap in backup LSNs in the contents. At that point, the primary would also release the bulk op lock so other backup operations could take place. And then each replica can do log truncation based on this last backup LSN. So the transaction log is we reuse sections. It's treated as a circular buffer, and we reuse segments of the log when certain conditions are met, including we can't reuse a section that hasn't been backed up, otherwise we lose that data. So that's one of the uses of the last backup LSN as well, is making sure that we don't overwrite data that we still need. When we advance the last backup LSN in this backup operation, that makes those areas of the log candidates for reuse, truncation. And that way each of the replicas can do their own truncation based on that. Restrictions and limitations. So for this release, the most significant restriction is that we don't allow differential backups on secondaries. The reason that we don't do that is what differential backups are, we maintain bitmaps spread throughout the database where there's one bit for every database page. They're cleared during a full backup, so bitmaps are all zeroed out. The first thing we do during a full backup. As pages are updated, the first time a page is updated, the bit is flipped in the corresponding bit in the bitmaps. And then when we do a differential backup, we just look at the bitmaps, and any bit that is set, we save the corresponding page. Pages that don't have the bit set, we skip. That's how we very quickly get the list of pages to copy in a differential backup. With availability groups, where you may be doing your backup on a secondary, which could potentially be significantly behind the primary in time, there's a really significant timing issue there, where if the primary happened to be at LSN 500 and the secondary that's doing the differential or doing the full backup was at LSN 200, when it started its backup, if the primary were to then respond by clearing the differential bit maps that it had as of LSN 500, while the secondary only copied data as of LSN 200, you can see that there's a gap there. So the next differential backup would start with the pages updated since LSN 500, because that's when the bitmaps were cleared. So you'd be missing all the updates that happened between 200 and 500, which obviously would leave you with a corrupted database because you've got a hole in your updates. That's not an acceptable situation. We have a design for a feature which will enable us to go ahead and do that, but for this release the restriction is you can't use differential backups because you can't do the clearing of the differential bitmap from the secondary. And the clearing again is done during a full database backup. So the corollary of that is database backups that are done on a secondary have to be copy only. Now the only distinction between a normal full database backup and a copy only database backup with copy only, is the copy only style backup doesn't clear the differential bitmap. There's no other difference. Transaction log backups are a different situation where copy only has different semantics. Full database backups, copy only means that we don't clear the differential bitmap. Because it's not getting cleared in that scenario, then differential backups don't work because they just keep getting bigger and bigger and bigger and would serve no purpose. So as of this release, the whole scenario of differential backups is not supported on secondary. If your configuration requires you to use differential backups to support your SLAs and your restore strategies, you can still do that with AlwaysOn. It just means that the full and differential backups have to be done on the primary node. You can offload log backups if you wish, but primary and differential backups have to be done on full and differential backups have to be done on the primary. One piece of advice is I would advise you to store all your backup files in a central location. That can be done either by doing the backups directly to a common file share, so that you write the backup directly to the share, or do the backups locally and then in the background copy them to a central location. There's a couple different reasons for that. First is at restore time, when everybody's in a panic because something went wrong, otherwise you wouldn't be doing a restore, right? People running around with their hair on fire, you want things to be as simple and straightforward as possible. And the fewer complications in your life at that moment in time, the better off everybody is. So if all your backups are in one place, you don't have to keep hunting around on different nodes and make sure you don't miss one. It's just going to make things much more success prone, as I call it, as opposed to error prone. The other reason for that is presumably the reason that you're doing backups is to guard against the situation where something goes wrong on one of your nodes. So one of your copies of your database goes down. If what goes wrong is that the node is completely taken offline due to catastrophic hardware failure, if you're storing some of your backups there, you just lost access to those backups. You can't use those backups in a restore. And if that happened to be some log backups right in the middle of the chain, then you can't restore all the way through. If your backups are all stored in a highly available local central location, that's not going to be an issue for you. So let's see what this looks like in practice. Here we have an AlwaysOn configuration. So AlwaysOn Serve 2 is the one that we're connected to. We have a collection of databases. Within availability groups, we have a backup on secondary availability group, which is the one we'll be working with today. this availability group has replicas on serve 2, 3, 4, and 5. And again, we're locally connected to serve 2. And within that availability group, we have a database BOS demo. So first, I have a couple tabs which are each connected to one of the different servers. And by running this query, you'll see that this tab is connected to AlwaysOn Serve 2, which is in the primary role for this database, for the database BOS demo. Flip to this tab and run the same query, and you'll see that this tab is connected to AlwaysOn Serve 3, which is in the secondary role for the database BOS demo. So that's the setup we've got for this demo. Now we're going to explore backing up from both primary and secondary replicas. So we have our database. We're going to create a table so we've got some data to back up, and insert a couple rows of data so we've got some data to back up. Flip over to the secondary tab, and the first thing I'm going to show you is that if we run the backup command without the copy only phrase, you'll see that you get an error. And that's the restriction that I talked about a bit earlier, where you must specify copy only if you're doing a full database backup from the secondary. Again, this does not apply to the log backups, as you'll see. So adding that phrase in, we see that the full database backup is successful from the secondary replica. Move back to the primary. We can add another row of data in, and take a log backup from the secondary. And again, you'll see that that works just fine. You'll notice that the backups that I'm taking on serve 3 go to a share that's on serve 3. And move back to my primary, insert one more row of data, and back up the log from the primary to show that primary backups work as well. And you'll notice that the backups I'm taking from the primary go to a server that's local to this server. I could just as easily have sent the backups all to one common share, but this makes for a little more interesting restore demo, which I'll show you in just a moment. So now that we've shown you how you do backups on either primary or secondary, shown that those both work, that situation works nice and smoothly, let's see how to do a restore using the recovery advisor that I described just a moment ago. So we've done backups from both primary and secondary replicas, and in those backups, the backup files were stored locally on the replica that they were backed up on, which means we've got backups on a couple different servers. And that makes restore kind of complicated. But this is a perfect chance to demonstrate another new feature in SQL Server 2012, which is the recovery advisor. So if you go into Databases, Restore Database, which is a fairly familiar activity, we're going to store from a device which is a backup file. Go to Add File, we choose a share for AlwaysOn Serve 3 backups. So even though we were saving them locally, they were shares, so they can be accessed remotely. And you'll see we've got both backups, and we're able to choose multiple files at once. And so that's the first difference, is that we can choose multiple backup files, both full database backup files and transaction log files. And now we also want to pick up the backups from the other server, which was serve 2. So change that and pick up these two transaction log files. Okay, so we've got all of these files, and in fact, from serve 2 I'm also going to pick up this full backup, which is an extra backup file. Hit OK. So, because we can't restore directly into an availability group, just as you can't restore into a database mirroring environment, we're going to give this database a different name, BOS demo restored, and also we want to not clobber the backup file or the database files, so we're going to relocate the files, data files, to this share, and log files also to the share. Options, we don't need a tail log backup. So come back here, and so we're going to restore the database there. You'll note the default is the last backup taken, so you want to restore to the most current point in time. One of the coolest features is this timeline view. So what you're seeing here is this range is the range of backups, range of times into which you can do a restore. So the most current backup file is this one. And these dark triangles represent the times when there's a full backup. So that's the original full backup. Transaction log backups cover this range. And this log backup, this full backup happened out here. And you can move the slider to any point within there. Choose a specific date and time. So anytime before that, okay, and move this timeline just a bit farther back in the past. You'll see the set of backup files changes. It automatically selects the backup files you need from the set that you gave it to bring the database back to the specific point in time that you've chosen. So from the full set that you specified, you can pull in the whole directory. It'll pick the specific backup files you need to get to the point in time that you want. So now we've chosen 4:12:52 p.m. and hit go. And it's just that simple. You don't have to restore the full, restore the log, restore the log, restore the log with stop at. All that is taken care of behind the scenes specifically for you. That's the way it works. Pretty slick. So now that we've seen that backups and restores can be done fairly straightforwardly on either primary replicas or secondary replicas, now we get to confront an interesting problem in the space, and that's how you construct an automation framework around this capability. How do you choose which replica should do a backup at any point in time? With database mirroring, it was a fairly simple scenario because only the primary worked, right? So what a lot of people did to configure backups in that situation was that they would have a backup job running on both the primary and the mirror node, both sides of the relationship, and whichever node didn't happen to be primary at the moment, those backups would just fail, and that would be an expected failure. And that way you would only do backups on one place at a time, and you wouldn't miss any because whichever node was primary would do the backups. Customers that were a little bit more sophisticated would write a script which had a preamble in it that did a simple query that says, am I the primary? If so, do the backup, otherwise exit gracefully. And that had the advantage of not throwing spurious errors. So you don't get the false failures that might mask real problems. With backup on secondary, that strategy no longer works because the backups would succeed on both sides. You can't depend on the backup on the wrong node failing. It won't. They'll both succeed, which is probably not what you want. Additionally, if you want to do the backups on secondary, you can't just ask, am I not the primary? Because that's no longer a unique answer. You can have multiple secondaries. Which one? Do all the secondaries do backups? That's not what you want. So there's more to the problem now than there used to be. The solution we're delivering with SQL Server 2012 is we've set up a framework to declare a policy. So you have a declarative policy on which node is the preferred node to do a backup at any iteration. The preference comes in a couple stages. The first stage is at the availability group, which is a collection of databases bound together for availability purposes. At that level, we allow you to declare a preference for what role should be doing the backup. If your program depends on doing differential backups, this is where you would specify, I want my backups to only happen on the primary. And that would return true that this is the preferred node on whichever node happened to be primary right then. You might want your backups to happen on secondary only. I have a workload that's sensitive enough I can never tolerate having my backups run on the primary, so even if there are no secondaries, I don't want to ever run backups on the primary. I don't expect that to be a real common scenario, but it's there because it was one of the obvious selections for completeness. The default setting, which we expect the majority of customers to use, is prefer secondary, but we'll use the primary as a fallback. So if there's a secondary available, we'll do the backup on one of the secondaries. If there's no secondaries at all, we'll still do the backups. It'll just happen on the primary. And the final setting is, I don't care what the role is. I'm going to use a different criteria for choosing which node to do the backup on. And that leads us to the next level, which is what is used to either decide which of the secondaries to do a backup if you're using secondaries, or if you set it for don't care, we allow you to give a relative priority for each replica. So this is in the range of 0 to 100, with 100 being the most likely, the highest priority for doing backups. What you would use this for is, for example, if you have one machine that has extra hardware for storing backups, it's going to be more efficient if your backups run locally on that machine. So you might give that a much higher priority than the other nodes. If it's not available, the other nodes will run the backup, but it's going to be much faster if the backups happen locally on that node. You might have one node that's in a remote location, and you really don't want it doing the backups. So you can set it down to a very low priority, or you can check the box which disables it, which effectively gives it a priority 0. In that case, it will never be chosen as the replica to do the backups. So how's this implemented? We have delivered a system function which returns a Boolean, 0 or 1, denoting, am I currently running on the preferred replica for doing backups? The logic within that system function is we look at the set of all the replicas for the database that you've asked us about. So you pass in the database name. We look at all the replicas for that database. We filter out any replicas that aren't up and online. Obviously, they can't be doing the backups. We filter out replicas that don't meet the policy for role. So if you've specified that you want the backups to happen on the primary, we'll filter out all the secondaries. If you've specified that you want the backups to happen on secondaries, we'll filter out the primary. So you're left with the set of replicas which are candidates to do the backup. We then sort that set based on the relative priority and select the highest priority replica to do the backup. If there's a tie among the priorities, we use the instance name just as a tiebreaker. It has no real other meaning built into it than that, but what it does is it gives us a stable answer. So every time you ask the question, you get the same response if you've got that configuration. So we've then decided which is the preferred replica to do the backup. We look and see, is that the replica I'm running on? If I am running on the preferred replica, the function returns a 1. If it's a replica that I'm not running on, so some other node, it returns a 0. The policy is advisory only, it's not enforced. So it's only intended to have any impact at all within the framework of an automation environment. And the way we expect it to be utilized is that a backup script would have a preamble up in the top which calls this function. And the function is fnhadr backup is preferred replica, and takes in the database name as a parameter and returns a 1 or a 0. So the script would be something like, if not is preferred replica equals 1, then we're just put out a message saying I'm not the preferred replica and exit gracefully. Otherwise, if it does return 1, do the backup. So you can see that that's intended to take place within the framework of the backup script. It has no impact on the backup command itself. So if you want to do a backup, if you have a reason, say type backup database into the query window, we'll do the backup for you. We assume you know what you're doing. This logic is automatically embedded in backup jobs that are created by the maintenance plan wizard or as log shipping. And again, it's implemented as a system function that returns a Boolean. If there's any reason why this logic that we've given you isn't sufficient for your needs, the way we implemented that function is entirely in T-SQL, and if you do SP help text on that function, you can get the whole SQL source out of the server. And then you can alter the logic any way you see fit to make it serve your specific needs. But we believe that we've covered at least 99% of the needs out there. So let's see how this works in action. So we've explained the automation features of backup on secondary, and now I would like to show what it looks like in action. So we have the same configuration, same availability groups. We have the backup on secondary AG with replicas on serves serve 2, serve 3, serve 4, serve 5, with serve 2 being in the primary role. Now we go to the property pane for the availability group and choose the backup preferences tab. And here is where you specify your preference for which role should do the backup. Whether you prefer secondary but will fall back to primary, choose secondary only and never specify primary. Whether you prefer the backups be done on the primary, or any replica says I'm going to use a different criteria. And falling down to that, we have backup priority, which would be the primary other criteria to use. So here we have serve 2 with a priority of 50, 3 with 51, 4 with 52, and serve 5 is checked exclude replica because it happens to be in a remote location. We don't want to use that for our backups. So with prefer secondary, we know that serve 2 is in the primary role, so it's not a candidate to this backup. 3 and 4 are both candidates, could be chosen for backup as far as the role is concerned. 4 has the higher priority, so we would expect that one to be chosen to do the backup. And again, the way it's chosen is by returning true from the system function. Backup is preferred replica. This connection is with serve 4, which was the one we expected to be chosen, and again it does return true. This is serve 2, which is in the primary role. We would expect that that would return false since we specified prefer secondary, and it does return 0. And finally we have serve 3, which is a candidate but is a lower priority than serve 4, so we would expect this would return a 0 as well, and it does. So let's go back into that property pane, preferences, and see what happens when we change the preference to primary to see if those answers change at all. So back up here, so we're back in the connection to serve 4, which returned 1 before we changed that preference. And now because it's secondary and we've requested that backups happen on primary, it now returns 0. Serve 3 is also in the secondary role, so we would expect it to return 0, and it does. And now serve 2, which is in the primary role, we would expect to return 1 since we requested that backups be done on the primary, and it does return 1. So let's look at how we would use this. I said that this is used for automation. So typically you would have a backup script that looks something like this. So you do some setup. In this case I'm hard coding the database name. We check the results of this function, which we've been looking at, and if it does not return 1, then we put out a message saying the server name is not the preferred replica to backup database and the database that you're backing up. And then we would fall through to the exit. So we'd put out a message and not do a backup. If the function did return a 1, then we would expect it to come through and actually do the database backup. So let's see what this happens. Again, this is running on serve 3, which is not the primary, and we've requested that backups be done on the primary. So we would expect to get the message from this query, which we do. AlwaysOn serve 3 is not the preferred replica to backup database BOS demo. And just to show that this is advisory only and is not enforced, even though the automation would have chosen a different replica, if for some reason I decide that I really want to do the backup on this node, issue it directly, the backups still work. We're not blocking it. It's only automation. And let's see what happens when we run the same script connected to serve 2. This is exact same script. We would expect it to return, the function to return 1, and therefore the backup to be done, which it does. So that's how it works. And logic very similar to this is embedded in backup database maintenance jobs when you created fresh under SQL Server 2012, and also in log shipping jobs that are created fresh. Jobs that were migrated from an earlier version, of course, won't have this logic in the job. You have to recreate them or create them fresh in a new installation. And that's how the automation works. Pretty cool.